Okay, kids, this is Mr. Felino back for you. We're going to finish off this section 2.4 stuff. I know there's a lot in it. We have two things to accomplish in this video. We're going to talk about one little last function evaluation problem that has a special place in calculus called the difference quotient. And then we're going to look at linear functions. We're going to look at them instead of equations and just solutions and graphs. We're going to look at that input-output relationship. That's what we're going to take care of there. All right, so this next problem is called the difference quotient. It has a special place early in calculus. So what we have is a curve in the maroon line of some function y equals f of x. And the red dotted line would be called the secant line because it intersects that graph twice. And so on that secant line, I have 2 points. I have this point right here, point A, and it has coordinates a comma f of a, understanding that my input into the function, my x coordinate is a, and whatever I'll output will be whatever. When I evaluate f of a, that's what I would get out there. And the second point is the point Q right here, and that has a x coordinate of a plus h. What that means is that the distance from this x coordinate a to this x coordinate over here is h, so that the total distance we've traveled horizontally is a plus h. And then the y coordinate that we get out of that is whatever the function evaluation is, f of that x coordinate, a plus h. And so we're going to find the slope of that secant line, and that's just going to be using the slope formula. So I'm going to have the slope equals, and I'm going to take my second y coordinate, which will be a plus h, minus my first y coordinate, f of a, and I'm going to divide that by the difference of my x coordinates, my second x coordinate, a plus h, minus my first x coordinate, a. If I perform a little bit of simplification on here, there's nothing I can do with the numerator simply because we don't know the function h, so we can't actually evaluate that. Remember, we can't factor. You may be tempted to try to, like, oh, look, I can factor an f out of it. But remember, that does not say f times. That says f of. So that's not a multiplication going on there. That is simply a function name. But in the numerator, where I have a plus h minus a, that would simplify down to simply give me an h. And so that is the slope of that line right there. So that slope of that secant line, m, right there, is the slope of that secant line. Now, what we do in calculus when you get there, one of the things about calculus is that they're going to bring these 2 points, P and Q, closer and closer together. Because what they want to do is find the slope of the tangent line. Now, for example, if I had some point right here, and I had the line that was tangent to my maroon curve right there, and I wanted to find the slope of that tangent line, that would be very difficult. Because to find the slope of a line, you need 2 points, but I only have 1 point. And this expression that we have right here that we're dealing with, this expression right here that we're dealing with, is our workaround for that by taking the value of h and making it smaller and smaller so that our points P and Q get closer and closer to each other until they're basically the same point. But your calculus teacher can talk to you about that. Until then, what we really want to be able to do is work with this expression right here. We want to be able to take this expression right here, and we want to be able to calculate values and numbers for it, and even expressions. Sometimes our answers aren't even numbers. They actually still have variables left in them. And then if we can do that, when we show up to calculus, we'll be able to calculate those values, those expressions, and then the calculus teacher will tell you how to interpret those. Now that result, that expression we had there, is commonly called the difference quotient. And it's called the difference quotient because if you look back at it, the numerator is a subtraction problem. And the answer to a subtraction problem is called the difference. And it's also a fraction because we're dividing by h, and the answer to a division problem is called the quotient. So it's called the difference quotient. And so we use that quite a bit, and we're going to do a couple of examples working with it. So in this particular case, we're going to simplify the difference quotient, f of x plus h, minus f of x, all divided by h, using the function f of x equals x squared plus 6x minus 4. So notice I don't have a's and h's necessarily. It can be any sort of symbol we want. So what I will start by doing is figuring out what f of x plus h is. Now, for this, what I notice is that in the definition, I used to have an x inside the parentheses. Now I've got an x plus h. So earlier on the last video, if you need to review this, it's just going to be substitution, that everywhere I see an x in my rule, I'm going to replace that with an x plus h. So that's all I'm going to go ahead and do. So that's going to give me an x plus h squared plus 6 times x plus h minus 4. And I'm going to put this in brackets, and you'll see in a moment that there's going to be a lot going on in this expression. It's going to be a little bit algebraically intensive. We're going to have a little bit of work to do here. And then we'll just move on from there. So that's my f of x plus h minus, and I'm going to put some brackets here already, f of x. Now, f of x is just simply going to be the rule. And now that's going to be divided by h. So at this moment, it basically is going to become some algebra that my numerator is going to become x plus h squared is x squared plus 2xh plus h squared plus 6h plus 6x plus 6h as I distribute minus 4. And then I'll go ahead and distribute the negative through the second set of parentheses, second bracket, and I'm going to get minus x squared minus 6x plus 4. And remember that that is all over h. I guess I don't need this bracket right here. That's all going to be over h. Now, if I start looking at terms in here, I notice that I have a negative x squared and a positive x squared, so I can eliminate those. I also have a positive 6h and a, positive 6x and a negative 6x. And even furthermore, I've got a negative 4 and a positive 4, which simply leaves me with an h squared plus 2xh plus 6h. Those are the three terms I had. Excuse me. Those are the three terms that I had left after I canceled. One piece of advice that I can tell you, and you should write this down, is that if you've done it correctly, in your numerator, each term is going to have an h in it. So that way I can factor an h out of each term, h plus 2x plus 6, close parentheses, over h. And now I can cancel the h's. And that leaves me simply with a final answer of h plus 2x plus 6. And the order of the terms doesn't matter. I mean, if you want to say it's 2x plus 6 plus h or whatever, I mean, it doesn't really matter. I guess I could put or there. It's not both. It doesn't really matter. And that's what we get. Now, granted, what it means in calculus, we're not going to worry about now. We want to practice, because this is kind of a difficult calculation. We want to practice being able to get these values ahead of time. So when we get to calculus, we'll just simply be able to do it, and we can worry about the interpretations later. Here's another one. Simplify the difference quotient for f of x equals 2x minus 7. I would recommend taking a moment here, pausing the video, trying it yourself, remembering that the difference quotient is f of x plus h minus f of x over h. Try that yourself. Use the previous example as your model, and then restart the video in a moment. Okay, let's assume that you paused and restarted it, and we're looking at this. I'm going to go through it a little more quickly this time, second time through. And so f of x plus h means, in the rule f of x equals 2x minus 7, everywhere I see an x, I'm going to replace it with an x plus h. So I'm going to have a 2x plus h minus 7. That's f of x plus h. Minus f of x, 2x minus 7. Now, having those brackets or parentheses are very important, especially with the subtraction, so that we can distribute the negative through the 2x minus 7. Because if we didn't have it, we wouldn't distribute, and we'd be off by a sign, and we would simply be wrong. When I distribute the 2, I get a 2x plus 2h. I'm going to have a minus 7. Then I'm going to have a minus 2x and a plus 7 all over h. Cancel any terms. I have a negative 2x and a positive 2x. I have a negative 7 and a positive 7, which leaves me with 2h over h. Cancel the h's. And in this particular case, I'm left with 2. So sometimes the answer will be a numerical value. Sometimes it will be an expression like it was in the previous case. Not a big deal. So that's the difference quotient. On to our second thing for this video, looking at linear functions. A linear function, f is a linear function if f of x equals ax plus b, where x is any real number and a and b are constants. This is just simply, it's a reworking of our y equals mx plus b. You'll start to see that we tend to use a, b, c, d in our formulas and definitions. If you think about your quadratic equations for a moment, ax squared plus bx plus c, it's just an extension of this ax plus b. In class, you've done linear regressions on the calculator, and you'll see when you push your linear regression calculation, it asks you to, it tells you it's going to give you in the form of ax plus b. It doesn't say mx plus b. And so that's just a reworking of that. Note that it doesn't have to be written in that form, but it can be written in that form. And when it is written in this form, this is called, not only this is a linear function, but this is a linear function in or using function notation. And we're going to start doing this a lot. We haven't done it to this point in this year very much, but we're going to start doing this quite a bit. So if we let f of x equal 2x plus 3, and we're going to sketch, find the domain and range, and determine whether the function is increasing or decreasing. So looping back on some of the ideas that we've been seeing here so far. So sketch the graph of f. This is pretty easy. I'm just going to make a quick sketch, give myself some sort of scale. And I can just use the fact that we have a slope of 2 and a y-intercept of 3. So my y-intercept of 3 is right here. If I have a slope of 2, so I'll rise 2 and run 1. I can work it backwards, go down 2 and backwards 1. I could do that a second time, and I get some points. And I have now sketched the graph of f. Find the domain and the range of f. Now, we can use this, and we can either think about this in terms of the function rule or the function graph. As a rule, you're just thinking about what values of x can I put into the function. If you recall from the previous video, our 2 pitfalls were negatives under even radicals. Well, I don't have any radicals. I don't have to worry about it. And also, it would be getting a 0 in the denominator. Well, I don't have a denominator there, so I can simply say that the domain of f, I didn't leave myself enough room there, the domain of f is going to be x is an element of all real numbers forever. Now, on the other hand, range is tougher to tell from the rule. So we look at the graph, and the range is the y's. So I am going to look at this graph vertically. I'm going to say, how high does it go? How low does it go? And does it cover everything in between? And the answer to that is yes. This graph will continue to go up forever. This graph will continue to go down forever. And it will cover everything in between. So now this range, now we're not going to start with x equals because we're talking outputs. We're talking y is an element of all real numbers as well. You may also see this instead of a y, we could very well put in f of x is an element of all real numbers because those two symbols are interchangeable. And the last thing, determine where f is increasing or decreasing. As I read my graph from left to right, because that's how I read graphs, I read them from left to right, I note that as my x's increase, my y's also increase. That means it is an increasing function everywhere. The whole graph is increasing. It's never decreasing. It's never constant. So I'm going to write for my solution here, I'm going to write INC as an abbreviation for increasing. And I'm going to put a colon there. And I'm going to put X, because when we describe where something is occurring on a graph, we use X's, is an element of all real numbers, which means everywhere. Infinity. I suppose if you wanted to use interval notation, you could write X as an element of the open interval from negative infinity to positive infinity. Those two representations are the same thing. So that's no problem at all. Either one, whatever makes you comfortable. So just a little intro to linear functions. Now, this is stuff that we've done before. Just reminding you, if f is a linear function such that f of negative 2 equals 5 and f of 6 equals 3, find f of x. Means write the equation. What is the linear function that works for that? Well, what we have to remember about these pieces of information that we have right here is our input-output relationship. I'm inputting a negative 2, and I'm outputting a 5. Which, if I convert this from function notation, it's really just the point negative 2 comma 5. And similarly, this other one, this one right here, is another point where we're inputting 6 and outputting 3. And now that I have 2 points, I can calculate slope. 5 minus 3 over negative 2 minus 6. 5 minus 3 is 2 over 8. So it's negative 1/4. And so now I've got my slope. And I can go either point slope form or slope intercept form to write the equation for f of x, just remembering that at the end of this, function form for linear function is f of x equals ax plus b. It doesn't matter. I'm going to go with slope intercept form because it is closer to the form that I want. So I'm going to say y equals mx plus b, where m is negative 1/4. I'm going to have to figure out b, the y-intercept. And I'm going to use one of the points. It doesn't matter which point I use. I'll just use the point 5, comma, 5 for y and negative 2 for x. So that 5 equals positive 1/2 plus b. And I can calculate then that b is going to be 9/2. So now I have my slope a, that was negative 1/4. I have my y-intercept b. So at the end of this, I simply need to write f of x equals negative 1/4 x plus 9/2. And I wrote the function f of x equals ax plus b. Just a reminder about notation. The most important thing probably here is being able to interpret something that's given to you as something else. I tell my students very often, when you're given something, don't look at it for what it is. Look at it for what it also could be. Just as a reminder of the phrase in terms of, in last section we saw that when we were writing for linear equations in section 2.3. Remember the basic structure is that it's going to be output in terms of and the phrase in terms of, I mean, I guess it could also be as a function of. Those two equivalent statements. Two equivalent statements there. And that'll help us write our equations as we go through. I'm going to do one word problem with you, and we're going to save the other word problems to work with you in class. So in this particular case, a steel storage tank for propane gas. Let me check our time here. That's good. Steel storage tank for propane gas will be constructed in the shape of a right circular cylinder of altitude 10 feet with a hemisphere attached to each end. The radius is yet to be determined. Express the volume V as a function of R. Now, a couple things. I know that my picture is not quite correct here. I need to put a hemisphere on each end. And I know that I probably really wouldn't see this piece right here because that would be behind there. I don't know if that helps or not. So I'm going to write a volume function. Remember, I'm not finding an answer. My task, this piece right here, means write an equation. My task is simply to write an equation where inputting the radius r will output for me the volume v. Now, there is no real formula for this shape, so I have to create one. And what I'm going to do is I'm going to say that the volume of the whole tank, and I'm going to put v sub t for volume of tank, is equal to the volume of the cylinder, v sub c, plus the volume sub s for the volume of a sphere. And so while there is no function for what we're working with, I can create one. And I'm just going to start filling some things in here. So I can say v equals, now the volume of cylinder is pi r squared h, and the volume of a cylinder is 4/3 pi r cubed. So that's not bad. Since we're expressing the volume v as a function of r, I've got v isolated on the left, and on the right-hand side, I've got pi. That's a number. That's fine. I've got r squared. That's what we want. We're going to have those r's. I've got that h. Now, that h is trouble because if I'm doing volume as a function of r, I can't have any h's on the other side. Continuing, though, across, my 4/3 is OK. The second pi is OK, and r cubed is fine as well. But my big sticking point right now is h. And I can't have that there. So I have to replace it. And sometimes when we make these replacements, some of the replacements are numbers, but some of the replacements are expressions. So I have to determine, in this case, what it is. And if I read back to the top of the problem, they tell me that the altitude of the cylinder, the altitude of the cylinder is 10 feet. Now, altitude, in this particular case, is a geometry version of altitude, which tells us the height or the length between the two bases of that. So it's 10 feet right there. So I'll just put that in there. And I'm going to put this in v of r notation, volume as a function of radius. 10 pi r squared plus 4/3 pi r cubed. And now I have a function that is v of r, that I'll be able to put in some value for r, of an r here and an r here. And I put that value in for r, and I'll be able to put out the volume. And now, there are some things we could do with this, whether it's really important or not. It depends on the problem. I mean, I could factor out an r squared and have a 10 pi plus 4/3 pi r. I guess I actually could have factored out a whole pi r squared and had a 10 plus 4/3 r. I don't know if that makes the problem any easier or harder. I think within this, I think any of these three would be more than acceptable as solutions. So just an introduction to writing functions. We do this a lot. We don't necessarily want the answer. We just want to practice writing that function. There's two more. If you see below the slide, I've got two more word problems in the slideshow that your teacher will do with you in class, I hope. And then we'll do some more practice problems as well in class. All right, so that concludes section 2.4. Go back, take a look at your list of things to know and things to do. Make sure that you understand all of them and that you can do them. Thank you.